So I explained margin of error a little bit in yesterday's video, so I wanted to just go ahead and explain it a little bit more just in case anyone has questions as they're completing the assignment. You don't really need to watch this video to complete the assignment, so if you looked at it and you already know what you're doing, you don't really need to watch the video. But in case you're kind of lost on the assignment, this should kind of clear some things up. So this is the first page of the assignment. You guys will be doing the second page, so I just wanted to use this as an example. This example talks about a study that they did to look at the amount of copper in people who have epilepsy. So they went ahead and they said they surveyed samples from 22 participants with epilepsy and 23 participants without epilepsy. And they wanted to compare, basically find the differences in the amount of copper, iron, zinc, magnesium, and calcium in those two groups. So they also, notice here they split it by gender, maybe to see if there's differences by gender. So notice they took some from each gender. So if that rings a bell, you should notice that's a stratified random sample because they took some males and some females, and they made sure they had them in both groups. And then they went ahead and took hair samples from them. So the first, number one, the first problem basically is asking whether or not we think that the presence of copper in the hair of all males with epilepsy in the world, so basically saying the entire population of males with epilepsy, do we think the average will be exactly 14? Well, if you look at the information that we have here, we have that the amount of copper in males with epilepsy is 14. But notice that number came from the sample of 22 people with epilepsy. And some of those people were male, some were female, so it's even less of a group of males with epilepsy. And remember, the sample number is just a number they got from the sample. They use that to make predictions about what they think the population's amount of copper will be in males, but that doesn't mean it's going to be exactly 14. They can use statistical inference to say that they believe it'll be around 14 for the entire population of males with epilepsy. So in number 2, it goes on to tell us that the journal article where the study was actually published had the results that reported that the males with epilepsy has an average of 14 plus or minus 9. And remember that 14 plus or minus 9 from yesterday's video means that 14 can be off by 9 in either direction. So it could actually be anywhere from, if we think about 14 minus 9 and 14 plus 9, it could be anywhere from, let's see what that is, 5. So it can be anywhere from 5 to 23. So basically, their margin of error is really high. Their sample was 14 on average, and they're actually saying, well, that with their sample data, they can predict the population will be somewhere within 5 to 23. Now, the thing is, think about it, why is their margin of error so high? Well, consider what we discussed in yesterday's video, that the error will be high, or the variability will be high, if the sample size is small. So in order to decrease the variability, they need to increase their sample size, because if you notice, their sample size is only 22 participants with epilepsy, and who knows what portion of that was males. So it's an even a smaller amount of a sample size for the amount of males with epilepsy. So therefore, that small sample size is creating such large variability, and that's a lot of error that they have going on. Alright, so now looking at number 3, it's basically just some information letting us know what margin of error is again. Now that is not a problem that actually needs to be done. It's just explaining what I basically explained now, that the margin of error is just the amount that the actual statistic could be off from the parameter. And then of course this bottom section down here is just asking us the very general question whether or not we've ever seen margin of error, in a news report? Well, I mean, if you watched yesterday's video, your answer to that should be yes at this point. But even before that, you guys probably have seen it before, but never paid attention to it. Because on any type of sports stations like ESPN, they actually report statistics often with margin of error, or just on the news. So now that you actually know what it is a little bit, maybe you'll pay a little bit more attention when they actually say it, because now you know what it means. So you guys will actually just be doing this page. It's that and that. I just clipped it in 2 separate pictures. I think the top part's pretty straightforward, just asking you, what would the range be if the margin of error was 3%, so I'll let you guys handle that without explaining it. But the bottom section, it's the same. It's basically telling us about a study where they adjusted rabbits' diets to a soybean diet to see if they gained weight. It sounds like in the study they wanted to increase the weight of rabbits. Probably, I don't know, maybe they sold them for people to eat. I don't know. But they wanted to fatten them up for some reason. So basically they were showing the soybean diet with this particular leaf meal stuff in it. And they showed, okay, if they had 0% of that in there, 5% of it in there, 10% of it in there. So as they increased the amount, what happens to the weight gain? So if you look at the numbers below, it shows that the rabbits weighed anywhere between 958 plus or minus 40. This one is 887 plus or minus 59, and etc. So they want us to give those ranges in a table. So I'll do the first one. So 0%, if it has 0% GLM, what would the predicted weight be for the population of rabbits? So if I just transfer that down here, and I'm just going to write this out to the side, 958 plus or minus 40. So if I subtract 40, that'll be 918. And then if I add 40 to this number, plus 40, it'll be 998. So we can expect that rabbits who eat the diet that has 0% GLM will basically have a weight of 918 to 998 grams, because it's measured in grams. So we could expect that to be their weight. So you would just go ahead and fill in the rest of the table like that, using the other relationships at the top as far as the different percentages with the different margin of errors. So hopefully that helps. If not, hit me up. Just let me know what your issues are, and I'll try to help you out.